10 episodes of making this agent more capable. Today we take capability away on purpose. Because the moment it stops running on your laptop, the interesting question is no longer what your agent can do. It is what it must not do, who decides that, and whether the thing deciding is a sentence in a prompt or a line of code. 10 episodes of making this agent more capable. It reasons, it searches, it remembers, it plans, it delegates, it criticizes itself, and it uses tools we did not write. Every one of those was an addition. Today is the first episode that takes something away, and it is the one that decides whether any of the others are allowed near a real customer. Because the moment your agent stops running on your laptop, 3 things become true that were never true before. It can loop, and a loop that calls a paid API is a bill with no ceiling. It can spend, in fractions of a cent, forever, on somebody else's card. And it can reach for any tool you left within reach, including the ones that write, delete, refund, or email a real human being. And none of that needs a new subsystem, because we already built the thing that knows about all 3. The tracer from episode 6 counts every step. It totals every dollar. And it is handed the name of every tool before that tool runs. Recording something and refusing it turn out to be exactly the same knowledge, asked at 2 different times. So the guard asks its question before the thing happens, never after. Before a tool, there is 1 question. Are you allowed to run this? Before a model call, there are 2. Have you gone on too long? And have you spent too much? 3 limits, in 1 policy object, sitting where the call actually passes. And here is the part one would tattoo on something. We are going to tell the model, in the system prompt, in plain English, that it may issue refunds. And then we are not going to let it. Because a prompt is a suggestion written in the same language as the attack, to a system whose whole job is to interpret language flexibly. If the only thing between your agent and a refund is a sentence asking nicely, that is not a guardrail. Never restrict an agent by asking it politely. One more idea, and then we write it. The guard raises 1 exception, but you get to choose what it means, and you choose it by where you put the try. Catch it around the tool call, and the run is steered. The refusal becomes an observation, and the agent finds another way. Let it out of the loop, and the run is stopped. Then, at the end, Evals, a handful of tasks whose answers you already know, run under the real policy, so that when you tighten a limit you find out in seconds whether you broke the thing. Let's look at the code. Here is the file, and it opens on something familiar. This is the same Nimbus handbook we have been looking things up in since episode 8. Rate limits, pricing, a refund policy, a support target. For facts about a product that does not exist, which the model therefore cannot possibly know, which is exactly why it has to use the tool. And the tools underneath it are the ones you already have. Lookup, which searches that handbook by keyword overlap. Calculator, char set locked since episode 1. With the 2 extra rules episode 10 added after a double asterisk walked straight through the character check and hung the process. And then there is this one. Refund takes an amount and moves money. It is not hypothetical, it is not commented out, and it is not in a different file. It is sitting in the same module as the harmless ones, because that is genuinely where it belongs. Every real codebase has one of these. All 3 go into the tools dictionary. This is the dispatch table the loop has used since episode 2, and it has no idea that one of these entries is different from the other 2. To the loop, a function is a function. Now watch the system prompt, because this is the part everybody gets wrong. We tell the model about all 3 tools, refund included, and the last line says, if the handbook says the customer is entitled to a refund, issue it. We are asking the model, in plain English, to spend money. And 30 lines up, the policy. 10 steps. 2 cents. And an allowlist with 2 names on it. Refund is not one of them. Read those 2 blocks together and you have the whole episode. The prompt says yes, the policy says no, and the only question that matters is which one the machine actually obeys. Because a prompt is not a control. It is a suggestion, written in the same language as the attack, to a system whose entire job is to interpret language flexibly. If the only thing standing between your agent and a refund is a sentence asking it nicely, you do not have a guardrail. You have a hope. So where does the real control go? We already built the thing that knows. the tracer from episode 6. It counts every step. It totals every dollar. And it is handed the name of every tool. Recording something and refusing it turn out to be the same knowledge, asked at 2 different times. So the constructor grows 3 arguments and nothing else changes. Max steps, max cost, allowed tools. All 3 default to none, which means off, which means episodes 6 through 10 still run exactly as they did before. A safety feature that breaks the previous 10 episodes is not shipping. Spent walks the steps and adds up the bill so far. The one subtlety is nesting. A delegation step gets its cost filled in when the child finishes, so while the child is still running you have to read the child's live total instead. Add both and you count every subagent twice. En route climbs to the top of the run tree. This matters more than it looks. A budget belongs to the whole run, not to each agent inside it. Give 3 workers their own copy of a 5-cent cap, and you have not capped anything at 5 cents. You have authorized 15. Here is the guard itself, and the shape of it is the entire design. It asks the question before the thing happens, never after. Before a tool, there is exactly one question. Are you allowed to run this? If the name is not on the allow list, trip. Otherwise return immediately. Notice what is not here. We do not check the budget before a tool, because our tools are local and free. Yours might not be. And before a model call there are 2 questions, because a model call is the thing that costs money and the thing that makes the loop go round. Have we taken too many steps? Have we spent too much? Both red numbers this class was already keeping for the pretty tree. Trip does 2 things in that order, and the order is the point. First, it records the refusal as a step, so the run tree shows why it ended. Then it raises. A guardrail that stops your agent without leaving a trace has turned a bug into a mystery. And when a run hands work to a subagent, the limits go with it. A worker cannot escape its orchestrator's policy by being a different tracer object. That is one line, and it is the difference between a policy and a decoration. Back in the agent. The tracer is built straight from the policy dictionary, so the limits arrive as data, not as code scattered through the loop. And now look at the loop, and at what is missing from it. There is no 4, in range, max steps. Every episode since the first one had that line. The cap moved into the policy, where it is one limit among several, and where a sub-agent inherits it. Guard LLM. One line, before the model call. Too many steps, too much money, and the run is over. Which brings us to the single most interesting thing in this file, and it is not a line of code. It is where the try blocks are. Here is the second call site, wrapped in its own try. Guard, tool, name, asked before the function runs. Not before it commits, not before it returns. Before Python ever looks the name up. And it is caught right there, 3 lines later. The tool never ran. The refusal becomes an ordinary observation and goes back to the model, which now knows something true about its own situation and can do something else. Call that steering. But this catches outside the whole loop. Nothing between the guard and here will stop it. So a blown budget or an exhausted step count takes the run down and writes a partial answer. Call that stopping. Same exception. Same guard method. 2 completely different behaviors, decided entirely by which try block catches it. Steer or stop. That is a design decision you get to make per rule, and I would encourage you to make it deliberately, because the default is whichever one you typed first. Which leaves the question nobody asks until it is too late. You just took capability away from your agent. How do you know you did not break it? So the file ends with 3 tasks whose answers we already know. 90, 588, 24. And a runner that is about 15 lines long. Every eval goes through the same agent, under the same real policy, not a special test mode. There is nothing clever here at all, and the absence of these 15 lines is why so many agents ship on vibes. The check is a substring, not an exact match. We are asking whether the agent got the fact right, not whether it phrased the sentence the way we would have. Hold a language model to an exact string, and you will spend your life updating assertions. And 2 columns beyond pass and fail. Steps catches the agent that got the right answer by flailing at it. Because today's 5 steps becoming tomorrow's 9 is a regression even when both pass. Cost is that same measurement in the unit your finance team reads. So let's run it. 3 scenarios, 1 file. The customer says support confirmed an outage for the whole billing month and asks for their $49 back. The agent looks the refund policy up, finds that the customer is genuinely entitled to the money, and does exactly what we asked it to do in the prompt. It calls refund. This is not the model misbehaving. This is the model behaving perfectly. And the tool never runs. The refusal comes back as an observation. The agent reads it, and it writes a genuinely good reply. You are entitled to this. I cannot process it myself. Here is who can. Steering, not crashing. And there it is in the run tree, step 4, in between the model calls. 6 months from now, when somebody asks why that customer never got their refund, this line is the answer, and it took no extra work to produce. Second scenario. Same agent, same ticket, same everything, except the budget is now 1/100th of a cent. Not a realistic number, just a small enough one to hit inside a demo. 1 model call and 1 lookup, and it is over. The guard fires before the second model call, and the run stops with a partial answer that says exactly why. 20/100ths of a cent spent, against a limit of 10. And again, the tree records it. This is what you want at 3 in the morning when a job stops halfway. Not silence, and not a stacked trace, but a step that says the budget ran out and here is what had been done by then. And the third scenario is the scoreboard. 3 tasks, the real policy, no test mode. 3 out of 3, and 15/100ths of a cent to find that out. That is the number to keep an eye on. Not because 3 passing tests is impressive, but because the day you tighten a limit and this drops to 2 out of 3, you find out in seconds instead of finding out from a customer. So that is Guardrails. A policy in one place, enforced where the call actually happens, recorded in the trace, and checked by evals that run the real thing. Next episode is the finale, and we put the entire season into 1 agent, and then hand the whole job to a framework to see what we have been doing by hand. So that is Guardrails. 3 limits in one place you can read in 5 seconds, a step cap, a budget, and a tool allowlist. All 3 live in the tracer, because the tracer already counted every step, totaled every dollar, and saw the name of every tool before it ran. The contrast we opened with is the thing worth carrying out of here. The prompt told the model it could issue a refund. The policy did not. The model did exactly what the prompt asked, and the refund still did not happen, because the allowlist sits on the path the call actually takes, and a sentence does not. Never restrict an agent by asking it nicely. And because the guard raises the same exception at both call sites, you choose per rule what it means. Catch it around the tool, and you steer. Let it out of the loop, and you stop. That choice is made entirely by where you put the try. Then the evals, 3 tasks whose answers you already know, run through the real agent under the real policy, with steps and cost beside every row. That is what lets you tighten a limit and know in seconds whether you broke the thing. Next episode is the finale. The whole season in 1 agent, on 1 real ticket, and then the server we do not own ships a tool that moves money. Code is in the description. Like, subscribe, and I will see you there.